Hey everyone, my name is Dr. Dan Grissom, and in this video tutorial we are going to talk about arrays. So specifically, we're going to look at single dimension arrays or one-dimensional arrays and two-dimensional arrays or 2D arrays. What is an array? An array is a simple data structure that allows you to basically assign more than one value to a single variable name, so to speak. So for instance, typically when I create an integer, I can store one number, such as 5 or 6. With an array, I can store multiple numbers attached to that same variable name. So what we see here is a declaration of an array, a single dimension array. The way that you do this is you have the data type of what you want to store, and then you have these square brackets, which is what tells me I have an array. So I have an array of ints right here. I'm going to call it array, so just to be clear, this is not a keyword, this array right here. Array is just what I happen to call this variable. It's a variable name. And then equals new, that keyword new, and then whatever data type you chose with the square brackets, and then the number of that type of data type you want to store. So what I'm doing here is I'm creating an integer array called array, and it can store 4 items. Now when you create a new array, I typically look at it as you see over here in the left, the conceptual view. I just look at it as like a row with a bunch of columns in it. Each one of these columns has a very specific what is called index associated to it. It's almost like an address. If I told you I live at 123 Main Street, then you would go to Main Street and you would find all the different houses, and maybe there was 8 houses there. You'd find the one with address 123. Similarly, I can use these indices. If I told you go find me the number at index 2, you would go to index 2, and then you would say, all right, well, it's this, it happens to be 0. When you create a new array of integers, it always just initializes the values to 0. So one thing to be aware about with an array is that every single, these are called elements, I have 4 different elements. Every element has to have some initial value. So when you create a new array of ints, it's going to initialize everything to 0. Same with doubles and floats. If you create a new array of, let's say, strings, it's going to initialize it to something like null, or a new array of objects. This is typically the main one you need to know about. It's because when you're initializing integers, what number does it start off as? So let's go through this simple code and see how this works. So when I say array of 0, you have these square brackets, and basically what I'm saying is go find index 0 and set its value to 5. Likewise, on the next line, go find index 1 of that array and set its value to 6. Go find index 3 and set its value to 7. Okay, I can easily overwrite a value, so go find index 0 and overwrite its value to 8. And then finally I can, so this is accessing it to basically overwrite it with some value. I can also just access it to do something like print, right? So in this case, system.out.print line array at index 0. So it goes and it finds index 0, which is an 8. So this line of code would print out an 8. Okay, so that's a single dimension array. Fairly straightforward. That's the basic mechanics, and this is typically how we look at it conceptually. One of the main things to understand is you have these indices. I just kind of typically use I to shorten for index. We always start at index 0 and we count up. So one thing to be aware of is if you have an array of size 4, the indices are going to go from 0 to 3. So for instance, if you have an array of size x, to be generic, the indices are always going to go from 0 to x minus 1. Okay, so we will unpack a lot more syntax and examples once we get to the code. But for now, I want to jump into some 2D arrays. Okay, now I'm going to start off with a little bit of a conceptual view, and I'm going to go through an example. And once we're done with the conceptual view, we're going to go through the same exact example again, but that next time we're going to look at it at more of a structural view. How are things really represented underneath the surface? But for now, this is how I typically teach it for brand new beginners. Okay, so I have some simple code up here, and then down at the bottom I have basically like almost a debugger live variable view. So you can see there's 3 different variables in here that I'm creating other than array, which we're going to show over here. I have this count, and then I have R and C. Okay, and now in this case, R and C both stand for, or they stand for row and column. Okay, so you can see it's kind of color coded there. Blue is used for the row, red is used for the column. Okay, so when I initialize an array here, notice that for a two-dimensional array, I have two square brackets. So in the previous example, we had int array, right? Int, I always just kind of read these as array. With this little bit of code, we have int double array, right? And so you can see here, I'm setting the number of rows to 3 and the number of columns to 4. Okay, so I basically can look at a two-dimensional array as a table. Okay, so you can see 3 rows and then 4 columns. Now, I'm not going to do 3-dimensional arrays or more, but you can have 3-dimensional arrays if you just add another square bracket right there. You can have 4-dimensional. You can keep going. Practically, single-dimensional arrays are obviously going to be the most popular. I often find reasons to have 2-dimensional arrays are a great way to represent any type of board game, or lots of board games like Battleship or Checkers or something like that, or just general tables. 3-dimensional arrays, I have occasionally done something like that in programs. I don't know that I've ever done a 4-dimensional array or higher, although you could. It's just kind of pushing the limits of most functional applications and what the needs are. There's probably a better way to do it at that point. Okay, so let's go ahead. You can see I'm going to set my counter to 1. Essentially what this program does is it just fills this 2-dimensional array with values from 1 to 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so this for loop right here, notice what we're doing. We're going to iterate through each row, right? So we're going to go 1 row at a time. And then as we iterate through the row, so I'm going to start off at row 0. So this first row right here, row 0. And then I'm going to iterate through every column in that row. So you can see what I'm doing. I have this array.length. This basically returns to me the length of this array, the number of rows, okay, which in this case is 3. Down here I can say array r, which is going to grab me in this case the 0th row, so this row right here. How many columns are in this row? So this is going to return 4 right here. This array r.length is going to return 4. Okay, and so essentially what's happening here is now I'm saying array at row 0, column 0, set it to whatever count is, which is 1, and then increment that value after you set it. Okay, so that's why you see the notation here. It's going to set it to 1, and then it's going to increment it to 2. And then I iterate back up, right? So I go back up to this for loop, and next time around I'm going to grab the value 2, and then 3, and then 4. Okay, once I'm to 4, right, I'm at the last column, so I've reached this C is less than 4. This now becomes a false statement. I'm going to jump back up to the for loop with the rows. I'm going to iterate up to 1, so now I'm going to be iterating through this next row. And then that same process, right? 5, 6, 7, 8. Okay, and then I'm at the end of that row, so I jump back to this outer for loop, and I hit r equals 2, right? So then I come back down and I iterate through the last row, so 9, 10, 11, and 12. Okay, so this code, you should get very comfortable with this idea that I'm going to have this nested for loop, this doubly nested for loop. Typically, we iterate through the rows and then the columns. So what that's going to do is that's going to give you that 1, 2, 3, 4, 5, 6, 7, 8 like you see here. If we were to have done the columns and then the rows, what would we have gotten? We would have gotten 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we would have just iterated it through it in a different pattern from top left to bottom right, going 1 column at a time instead of 1 row at a time, which is how we do it with rows and then columns. So it's really up to you, what your particular application is, but this is typically the way that I iterate through these. Okay, so now let's look at the structural view, what's really happening underneath the surface. And underneath the surface, it's going to be pretty similar, but this is just to emphasize that what is a two-dimensional array? All it really is it's an array of arrays. Okay, so instead of each element really being its own integer, what we really see is I have this array the first index, right, the number of rows. Okay, so I typically draw the first one downwards, right? So you can see I really just have an array with 3 elements, right? And I just have them as indices 0, 1, and 2. They just happen to represent a row. Okay, so this outer array is representing the columns, and I typically draw those downwards. Each element of that outer array has its own inner array inside of it. Okay, so you can see each one of these has an array of size 4 inside of it. So 0, you can see 0, 1, 2, 3, 0, 1, 2, 3, and 0, 1, 2, 3. Okay, so that's the structural view. This is how it really is organized. So if I had a 3-dimensional array, then inside of each one of these elements would be another array of however many size. If I had another square bracket here and then another square bracket here of size 5, then instead of there being a 0 in here to initialize, there would be an array of size 5 with 5 zeros inside. Okay, so otherwise, this program is going to work the same. It's just the structure view is, you know, just a little bit different. But we're still going through the same pattern, 1, 2, 3, 4, like that. Okay, so I'll just kind of step through this slowly. No real new explanation here. It's just that the view that you see over here is just a tad bit different. Okay, so that is the kind of conceptual and structural view of the 1D array and the 2-dimensional array. And arrays, typically, you're going to want to use arrays anytime you know exactly how many items you have in the array. What we saw here is we defined exactly the size of our array, a 3x4 array. Or earlier when we did the 1-dimensional array, we had assigned an array of size 4. One thing about arrays is that they cannot change in size. So when I declare this array as having 4 elements, it will always have 4 elements for the lifetime of this variable. I cannot chop this down to a size of 3. I cannot append something else to a size of 4. Okay, so if you are absolutely sure you know how many items that you want to store inside of your array, then use an array. It's the absolute smallest space you could take up in your memory to store these variables. However, if you don't know how many items you need, then you probably want to use some kind of a list. So typically I would recommend an array list, although you could also use a linked list, and there's probably some other options, but I would say 99.9% of the time I'm either using an array if I know exactly how many items I want to store. Let's say it's a game board. The size of the game board is not going to move. I'm creating a battleship game. It has a 10 by 10 board, right? An array works fine for that. However, if I have maybe a list of students and I don't know how many students are going to be in my class, maybe I have an array list, right? Because students may add and drop, so I don't want to be stuck with 20 students when maybe 3 more are going to enroll at the last minute or something like that. Okay, so with that said, let's go ahead and jump into some code. Okay, so I have a simple, just kind of a template set up here, and we're going to look at array functionality here. We're going to start with some constructors, and then we're going to look at a number of methods. So we're going to look at methods such as, and these are arrays methods, toString, asList, sort, binary search, CopyOfRange, fill, and length. And then there will be a pretty heavy emphasis as well on iterating through both 1-dimensional arrays and 2-dimensional arrays. We'll show you how to do kind of a quick and dirty print, as well as a kind of a nicer, prettier print, so to speak. Now this program, I'll just kind of walk you through the comments here to kind of give you an idea of what we are about to create. So what does this program do? You can see I have a random number generator at the top, and we'll explain that in a second. But we're going to start off by declaring and initializing arrays for quiz participants and question results. Okay, so essentially what we are going to do is we're going to create a program that simulates a quiz. Okay, so students are going to be able to answer 20 true-false questions. We are going to basically save the results of each of those questions, and then we are going to score the quiz and print out all the different results, and then we're going to do some basic analysis on those results. Okay, so we're going to simulate the quiz results. We're not going to ask our user in the console to answer questions just for the sake of time. We're going to simulate that, which is where the random number generator comes in. Okay, We'll do a quick and dirty print, then we'll do a formatted print of the 2D array so you can really kind of analyze, hey, on question 5, what were the results? How did students do on question 5? Or how did Jenny do in general? Okay, so we'll walk through that in just a second. And we're going to assume that everyone gets a 50% for their participation score, and then they're going to get 5% for each of the remaining 10 questions that they answer correctly. I might have said 20 questions earlier, but I'm going to do 10 questions. Okay, and sorry, no, I will do 20 questions because they're each 5%. Okay, so at the very end, we're going to sort the arrays of grades and then search for a specific grade, and then we're going to get the top 50% of the grades for analysis. And then finally, we'll convert it to a list so that if you wanted to, you could actually add more elements to the grades. Okay, so let's go ahead and get started. Okay, so the first thing I want to do is I want to start creating some arrays so I can really start to begin collecting data. Okay, so the first thing I'm going to do is I'm actually going to create a single dimension array of just the names of my participants. So let's just say I already know exactly who's going to participate in this particular quiz. So I'm going to create a string array, okay, because this is for names, so it's going to be an array of strings. I'll just call this maybe just a participants. Okay, and we'll say equals new string array. Okay, now if I want to hard code the initial values of an array, what we do is we simply put after the new and then the data type and then the array square brackets, I do an open and a close curly brace followed by a semicolon. And then inside of those curly braces, I simply put my values separated by commas. So in this case, I'm going to do Alice. I'm going to have Bob, not Blob. I'm going to do Chad and Dan. So I'll take the quiz myself. Okay. So from there, I can get the number of participants by saying int num participants is equal to a participants. And what you'll notice is that's my array, my string array. I can call dot on that variable, and you will see a few things that pop up. Really, the only method that I typically use here is the length. Sometimes the toString, but the length is the most popular one. And what that gets me is it's just a programmatic way to actually grab however many items, the number, right? So in this case, it should return to me 4. Okay, and we'll see that will be true in just a moment. I'm also going to create a variable for the number of questions, and I'll set that to 10. Okay, so I'm just going to kind of hard code that. Okay, so now what I want to do is I want to store, this is where I'm going to create a two-dimensional array. Okay, I want to have a two-dimensional array where basically the rows are participants. Let me change participants to people just to keep it a little bit cleaner here. So I'll just change this to people. Might be a little bit easier for you guys, people. Okay, so the rows are people, and then the columns are questions. Okay, so each row represents all the different answers for all the different questions for a particular person. Okay, so I'm going to go ahead and create a Boolean two-dimensional array. So I do Boolean as my data type, and then I have the 2 square brackets, and I'll just call this something like a analysis, right? It's going to be the kind of the in-depth analysis of all my question results. Okay, and that'll be equal to new Boolean. All right, and then two array elements there. And again, what I'm going to have here is my num people is going to be the rows. I'm going to have num people rows by num questions columns. Okay, so what I can do here is I can pass in to my first index, which is representing of the rows, the num people. And my second square brace or square bracket, I'm going to pass in num questions. Okay, so what I just did was essentially I just created a two-dimensional array with 4 rows in 10 columns. Okay, now We'll print that out in just a little bit once we kind of get a little bit further in our code. But for now, just kind of take my word for that. Like I said, I'll for sure prove that to you, and we'll print it out very nicely in just a minute. Okay, so the next thing that we want to do is go ahead and create a final. We'll create one more array to hold the final scores. So you can see here, I'll do an int array. I'll call this a scores, and I like to just kind of add a prefix to my variables of a just to let me know as the programmer that this is an array of this data type. It's not just a data type. And that makes it really nice for if you're using a integrated development environment like Eclipse or something else for auto suggestion. If you know you have an array but you can't remember what it was called, you can just kind of type something like a and then have that auto suggest come up with a control space or something like that. So it just makes the coding process a little bit easier. Okay, so int array a scores is equal to new int, and I'm going to pass in num people here. Okay, and this is going to hold the whole number percentages. Okay, so for example, something like 50 or 80 or 95. Okay, and all of these being percentages. Okay, all right, so we have defined all these arrays, right? We've got the first one is a single dimension array with just the people's names. Second one is a two-dimensional array where the rows represent the people and the columns represent the questions. And then finally, one more single dimension array where it's storing all the percentages and of each person. So a people is kind of going to be tied together with a scores, meaning index 0 of a people is for Alice, index 0 of a scores is going to be Alice's score, and so on and so forth. Okay, so let's go ahead now and simulate the quiz results. So what I'm going to do is I'm basically going to iterate through that single dimension array, or I'm sorry, that two-dimensional array. So just like we did in the presentation at the beginning, and I am going to set the value of each of those elements. Okay, so if you recall, we typically are going to do that by iterating through the rows and then the columns. Okay, so I'm going to start off with my outer for loop for int r equals 0. Okay, now typically when I write a for loop, I'll do int I equals 0. But when I'm doing two-dimensional arrays, I always use r and c for my variable names for my for loop, because it's just a little bit more intuitive. Because R and C are single letters and they actually mean something a little bit more relevant than maybe I and J, which is what you'd probably use in a two-dimensional or a nested for loop. Okay, so R, I'm going to loop while R is less than num people, and then R plus plus. Okay, and then the next part is going to be for int C equals 0. C is less than num questions, and then C++. Okay, and I'm going to go ahead and just kind of have a printout statement here. So I'll do system.out.printf, and I'm going to say simulating results for, I'll do %s, and I'll fill that in with a name. Do a colon, I'll do a new line, and then I'll do a tab. And then I'll say answered correctly, the space. Okay, and I'm simply going to replace this %s with one name. Okay, so what I'll do here is I'll say a people at index r. So if I run this now, what we see is we have simulating results for Alice, answer correctly, simulating results for Bob, simulating results for Chad, and for Dan. Now the formatting is a little bit off, but that's just because we haven't quite finished our for loop yet. We'll fix the formatting as we write a little bit more code, but I just wanted to show you that we are iterating through every single element in this a people array, right? We're iterating because num people was the size of this array. Okay, so let's continue on. All right, so for each person, right, I'm going to simulate the results for Alice, and that means I'm going to have to ask Alice the 10 questions. Okay, so we're going to go ahead and simulate her answer for each of these questions. So I'll create a Boolean, answered correctly, and that's going to be equal to random dot next Boolean. Okay, so this random number generator can also generate random Boolean outcomes. So it's just going to randomly generate either a true or a false. Okay, so I'll go ahead and I'll just print out the result of that now. So I'll say system.out.printf, and then I'm going to format it this way. I'm going to say like Q1 is true, Q2 is false, or something like that. So I'll say Q %s. I'm going to pull the question number from my variable C right here. And then I will do a %s with a T. So this is going to be the true or false value. And I'm just going to put tabs in between each of these. So that first %s is going to get replaced with C plus 1. And then the second one with my answered correctly variable. Okay, so if we play this again, it's still going to look a little bit probably off. You can see simulating results for Bob is at the end of the line. Okay, so let's go ahead and add just a simple system.out.print right here, and I'll even go ahead and add a new line, two new line characters to give it a little bit of breathing room. Okay, so now you can see simulated results for Alice, answered correctly, Q1 false, Q2 true, Q3 false, Q4 true, and so on and so forth. Okay, I want to be clear that true and false is whether they answered these correctly. It's not whether they chose the answer true or false. It doesn't really matter if these are true or false questions they're asking, or multiple choice, or just free form. This true or false is basically, did they get the points or did they not get the points for that question? Okay, so at this point I'm basically simulating all these different question results for these 4 people. You can see they're all different. So the last thing I want to do is I actually want to save the results in my 2-dimensional array A analysis. So I'm going to say A analysis at row column is equal to answered correctly. Okay, so now not only am I printing out whether they answered correctly, I'm also saving the results in this 2-dimensional array. That way I can come back and I can actually print these results later on. Okay, all right, so let's continue on. At this point, I'm telling you that we have filled out this 2-dimensional array. Let's actually kind of print it out and see. Now, the first thing I'm going to do is I'm going to do what I call a quick and dirty print. Okay, this is a very poorly formatted print of this 2-dimensional array, but it's kind of nice and quick and easy. Okay, let me actually show you on a 1-dimensional array first how to do this, and then I'll show you on a 2-dimensional array, because it's going to be just a little bit more involved, not much. But let's start on the simpler example. At the very beginning, we created this 1-dimensional array, Alice, Bob, Chad, and Dan, and then we iterated through it and kind of printed them out the way that we wanted with the simulating results. I could have also said something like system.out.print, and then I use this arrays class. Okay, I can say arrays.toString. You can see there's a bunch of toString versions, and then I just pass in a people. Okay, and if I were to run this code, you can see it literally prints out Alice, Bob, Chad, and Dan within these square brackets. Okay, so it always adds these square brackets and just commas, everything's on one line. So, I mean, that's kind of nice for debugging, but that's typically not the way that I want to print this out to the user. I typically want to print it out in maybe like a sentence or something, just more nicely formatted for the user to really make sense of it. So that's how you would print out a 1-dimension array. Let's go ahead and look at a 2-dimensional array. Okay, so in this case, if I go ahead and I say something like system.out.print, let's go ahead and I'll start off with print line, and I'll say arrays.toString, and I will pass in my A analysis. Okay, that's my 2-dimensional array. And I'll play this. And notice what I get here, my quick print of quick results. I'm getting something a little odd. It's all these kind of gibberish. What you'll see, the commas show me that there's actually 4 values in this array, right? 1, 2, 3, and 4. Okay, if you think back to where we started with our slides, the structural view, what did we have? We actually had that a 2-dimensional array was an array of arrays. Okay, so in this case I had 3 rows, 4 columns. So I had each of my elements represented a different array. Okay, so similarly, when we created this two-dimensional array right here, we had 4 rows. Okay, so this is actually what you're seeing. These are actually the addresses of each inner array. Okay, so when I'm printing a two-dimensional array, what I actually want to do is, instead of calling arrays.toString, I want to call arrays.deep2string. Okay, and I can call it just the same. It's just deep2string instead of toString. But when I play this, it'll actually kind of realize, oh, this is a two-dimensional array or more, and I'm going to actually dive down into those arrays and print out the actual elements that you're probably meaning to pass out. So you can see here, it's still not very pretty. It's technically correct. You can see here's the first. This would be Alice's, right? False, false, true, true, false. You can see that. Let me pull this up a little bit. False, false, true, true, false. And then here's the second one for Bob. False, true, false, true. False, true, false, true. So you can see it matches. You can see this is the first inner array, and then the second inner array for Bob, and so on and so forth. Okay, so let's go ahead and just kind of finish out this little example. I'm actually going to change this print line to a printf, and then I'm going to, in my formatted area, I'm going to do a tab with the %s, and then I'll just add 2 new lines in there. Okay, so this way it just kind of formats it the same way I've been doing it. We'll tab it over and then add some spacing underneath. Okay, so this is the quick and dirty print, just to kind of get it out there for debugging if you really don't want to waste time writing code to really look at it nicely or kind of pretty, so to speak. But I probably do want to print it out a little bit nicer. So let's go ahead and continue on printing a formatted version of this 2D array. Okay, so there's going to be 2 pieces involved. I'm going to print a header at the beginning so I can actually kind of show the column names and whatnot, and then I'm going to print the body. I'm actually going to go ahead and start with the body first. This will be the easiest part, not necessarily the easiest part, but just kind of the pure data portion, and then I'll kind of show you how adding the header, basically the row names and the column names are going to make this formatted version a lot nicer and easier to read. But let's go ahead and do the body. Okay, so very similarly, we are going to iterate through those rows and columns. Okay, so I mean, it's up to you how you want to do this, but you probably have written this code already, so it's always nice to just grab it and copy it and paste it, because you're going to be iterating through this many times. So I'll go ahead and just kind of, we'll go ahead and have the simple for loop. So for int r equals 0, r is less than num people, r++. For int c equals 0, c is less than num questions, c++. Okay, so remember that's going to iterate through each row, each column at a time. Okay, so what I essentially want to do right here is I want to print out each of these elements. Okay, so system.out.print, and I'll do a printf. Okay, and in my formatted print, I'm going to have a %s followed by a tab. So I'm just going to give some spacing between each of my elements. And for each of these elements, I'm simply going to print out a analysis at row column. Okay, so I forgot the F right there. All right, so when I play this, what you'll see is I've got all these results, but notice they're all in the same line. Okay, so when I have a two-dimensional array, it's going, here's basically 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are all Alice's responses. The following are Bob's, right? So we need to add a new line character at the end of every row. So once I've iterated through every column, we always want to add one more system.out.print line, and that'll give us a kind of a nicer sheet. Now you can see I have 4 rows for Alice, Bob, Chad, and Dan, and then you can see I have 10 columns. Now, true and false, you can keep that. I would probably prefer to print out something a little bit more concise. You could do maybe a T or F, but I think T or F are, they're a little bit easy to confuse to the eye. If you think about T and F, they're actually pretty similar in terms of their shape. So what I like to do is actually, I'm going to print out zeros and ones instead. So I'm going to use the ternary operator. I'm going to say question mark, okay, If this is true, then I'm going to print out a 1. Else, if it's false, print out a 0. Okay, so when I play it now, you can see it's just a little bit cleaner with the 1s and the 0s. Okay, so that was a formatted print. But what I want to do now is I want to add a little bit more details, right? I want to be able to see, oh, this is question 7, right? This is question 7. Oh, this is question 2. Oh, this is Chad's row right here. I kind of have to look at the raw data or count the number of columns to get that information right now. So let's go ahead. The first thing I want to do is actually add, we can just real quickly add the row names over here. Okay, so how do I do that? Right at the beginning of every row, before I start printing out the column data, the actual quiz results, I'm simply going to print out, I'm going to do a system.print.f, and in my formatted statement, I'm going to add a tab. I'm going to do the %s, which is going to be the name, followed by a colon, followed by another tab. And then I'm simply going to replace that %s with a people at whatever row number I'm working through. So now when we play this, you can see, oh, this is Alice's questions. This is how Alice did. You can see Alice missed the first 3. She got the next 2 correct and missed 2, and then she got these 2 right, so on and so forth. All right, so now the last thing I want to do here is I want to actually be able to say, all right, well, which question was this? Right? Well, I can count 1, 2, 3, 4, but I'd rather there be a column header for each of these different columns. So let's go ahead and add our header at the top. Okay, so you can see here formatted print of quiz results. Okay, so the first thing that I am going to do here is I'm going to iterate through the number of questions. Okay, because essentially I want to add the columns here. Okay, so for int c equals 0, c is less than, and I'm literally using the same column for loop that I always use. I'm just writing this one out from scratch. So c is less than num questions, c++. Okay, and what I'm going to do here is I'm just going to say system.out.printf, and I'm going to just do the quiz question number. So I'll do a capital Q with a %s followed by a tab. And I'm just going to replace that %s with c plus 1, because I don't want to say question 0. I want to start at question 1. Okay, and then at the end of that, I will do a system.out.println. Okay, so what we see is we see quiz 1, 2, 3, and that looks pretty good, but what you see is it's not quite tabbed over, so we want to add a few tabs there. Okay, so before we actually even go through that for loop, what we want to do is actually system.out.print, and we'll just add 2 tabs at the very beginning. And what that's going to do is it's going to shift these questions over a little bit. So now you can see question 1, 2, 3. So that's pretty good now, right? We see, oh, Alice question 5, she missed it. Chad question 7, he got it right. We can see there was no questions that everyone always got right. Maybe if we do it again, we can see, oh, question 7 was really easy. Looks like question 8 was really hard for whatever reason, right? Okay, so I'm going to add just a little bit more formatting here. And what I'm going to do is I'm going to actually add, going to copy and paste this line right below. Okay, and then below, instead of doing the Q %s with a tab, I'm just going to do 2 dashes, and you can see it's going to need to be tabbed over a little bit. So I'm going to change this print line to a print, and inside of it, I'm going to do a new line followed by 2 tabs. Okay, so this way it kind of gives it a little bit of almost like a header. Okay, and you can see that our Alice is also not quite set up properly, so we need to add one more print system.out.print line at the very end of this to make sure Alice goes to her new line down there. Okay, so you can see now it's very clean. We kind of have a little bit of separation from the column headers from the data itself, so it doesn't all get jumbled together as one big piece. Okay, but this is a formatted results of a two-dimensional array where we are actually printing the column headers along with the row headers with the data. So it's a much nicer, cleaner presentation than especially something like this. Okay, perfect. So let's keep on going. And now what we're going to do is we want to actually compute a score for each participant, each person, right? So Alice, it looked like she got 1, 2, 3, 4, 5, 6 questions right. Each question is worth 5%. Okay, so that gives her 30 points. Just for taking the quiz, she gets 50 points. So she should have got an 80% for this particular quiz that she took. Okay, so let's go ahead and continue on. Okay, so now we are going to initialize each score to 50%. So I want to have my array that I already created a long time ago, A scores. Okay, the A scores are going to hold all of our scores. Okay, so let's go ahead and initialize it. Well, it's already initialized. Let's go ahead and print it out just to basically see what's in here. Okay, so if we do something like this, system.out.println arrays.toString auto suggest kind of wrongly predicted, arrays.toString, and then I'm going to do A scores. Okay, so by default, all my scores are going to be zeros. Okay, what I want to do is I want to initialize so that, hey, everyone who took the quiz at least gets a 50%. In order to do that, I can use the arrays method fill. How do I do that? It's very simple. Arrays.fill, and you can see it takes in two parameters. One is the array that I want to fill with some value, so I'll give it A scores. And then the second parameter is the value that I want to fill it with, so I'm going to say 50. So what we will see if I run this line of code both before and after, you'll see it's initialized with all zeros. After that fill method, it now has all 50s in there. Okay, so now I have my array initialized with all 50s. Go ahead and I'll comment these out. These are just kind of for debugging. And I'm going to iterate through. Okay, so I'm gonna go ahead and grab my nested for loop, so the for each row and for each column. I'm just gonna delete this little part, so just get the structure set up for our for loop. I'm iterating through each row and in each column. And all I'm doing now is I'm gonna say A scores at R. Okay, so this is basically updating the score for each person, right? So I'm going to start off with R equals 0, which should be Alice, okay? And then I'm going to say, all right, we'll iterate through each question, right? So it's going to look at this question, and then this one, and then this one, and then this one. And I basically want to add 5% if there's a 1 here, and I want to add 0% if there's a 0, right? If they got it right, I'll add 5%. Otherwise, don't add 5%. Okay, so A scores is directly proportional, directly related to the rows here. Okay, so what I can do is I can say A scores R is equal to, what I actually want to do is say plus equals to A analysis at R C. And A analysis is a two-dimensional array of booleans. So I basically want to convert that. I'm going to use the ternary operator. I'm going to say if that's a true, then I want to basically add 5 points. Otherwise, add 0 points to the value in this particular array. Okay, so I'll go ahead and print this after the results. Since I only really have one line of code in this for loop, I can delete the curly braces. Don't need them. Okay, and now when I play this, we should see the scores. Okay, so 80. That means that Alice got 30%, right? Which is 6 questions, right? 1, 2, 3, 4, 5, 6. Okay, you can see Bob only got 70%, which means he only got 4 times 5%, right? 4 questions, right? So you can see 1, 2, 3, 4. So it appears to be working properly. I'm updating these scores. So let's go ahead now, and we kind of have this quick and dirty print done. Let's actually go ahead and do a much more like a cleaner print here. So let's print the final results for each participant. Okay, so we've already got a little bit of a header printed here. So I'm just going to do my basic for loop. Just grab my, going to for loop through each person. So for int r equals 0, r is less than num people, r plus plus, and I'm just going to do a system.out.print f, and I'm going to format it this way. I'm going to do a tab with a %s. That's going to be the person name, followed by a colon, a tab, and a %s. Okay, and then I'll go ahead and add a new line in there. And then this first %s is going to be the person, right? So a people at r, and the grade associated with that person, so a scores at r. So now if I print this, you'll see quiz scores 80. Looks like everyone got an 80 this time. If I run it again, that'll be different. Okay. Now probably I want to put the % in there, and I just left that out for a moment because it's a little bit odd when I'm doing this printf. % is that special character that tells me how to format it. So if I just try to put a % in there, you'll see it's going to give me some kind of error. You might think typically we'll just do the escape character, \%. Doesn't work, right? I get a compiler error that time. So just as a little quick reminder, if you do actually want a % within the printf, you actually do a double %, because the % symbol is that special symbol. So you can see now Alice 70%, Bob 65%, Chad 65%, and Dan 80%. Okay. All right, so let's keep on going. And we're almost done here. Now we're just going to do a little bit of array analysis here. Okay, so we're going to sort through and search for a perfectly average student. So essentially what I want to know is there a student who scored exactly a 75%? Okay, so that's a perfect C, right? You're perfectly average if you scored a 75%. So what this is really getting at is search. Can I search through my array to see if a very specific score exists? Okay, and the answer, of course, is yes, I can do that. But in order to do that, there's a few ways we can do that. In some sense, I would need to search through every single score to see what I come up with. We're actually going to use something called the sort method, which depends on all the data being sorted. Okay, so let's go ahead now, and I'm just going to kind of do a little print header, so system.out.println, and I'll go ahead and add maybe one more new line character that adds some spacing, some interesting quiz statistics. Okay, so what I'm going to do here is I am actually going to go ahead and, let's see. I'm going to go ahead and search for this particular value. Okay, now I'm going to forewarn you that this is not quite complete as I'm going to start off. I'm going to basically show it to you a little bit broken so that you can see why we need to do, we're going to have to do a pre-sort before we search. Okay, so I'm going to use a new method called binary search. Okay, and essentially what I can do is I can say if arrays, so arrays is the class that we're calling this method off of, arrays.binary search. Okay, how does binary search work? Essentially, it takes in a first parameter, which is the array that we want to search through. So in this case, it's going to be a scores. Okay, and then the second method is the key. What are we searching for? So in this case, I'm searching for a 75%. Okay, so basically search through a scores for a 75. What is it going to return? Well, it's going to basically return the index at which it found 75. Okay, if it does not find it, it is going to return a value, a negative value. Okay, so essentially what we can do is we can say if binary search searches through this array, for 75 and it finds it, it's going to return a value that is greater than or equal to 0. So in that case, I'm going to print out, I'll just do a system.out.print line, and I'll do there is a perfectly average student in your class. Else, system.out.print, there are no perfectly average students in your class. Okay, so let's just run it a few times and see what happens. Okay, so in this case, 75%, it seems to work, right? There's a perfectly average student in your class. Let's run it again. Looks like it's working, right? Alice got a 75. There is. Looks like it's working. This time, however, what happened? There are no perfectly average students in your class. However, if we look at our class, we can see that Chad was a perfectly average student. He got a 75%. Okay. Now, I'm not going to go into the mechanics of binary search because that could be a whole video lesson in and of itself. What I will say is that binary search essentially cuts the array in half. Binary search assumes that our array is actually ordered data. Okay, so if I go ahead and I'll do a system.out.print line, and I will say arrays.toString, and then I will print out a scores right here. Let's take a look. Okay, so let's you can see there was no 75. I'm going to get one where it's working or it's broken. Okay, essentially how this works is binary search assumes that all these values are in order, and then it just checks the middle element. Okay, so it will look for the middle for 75 and it'll say, all right, well, was this middle element 75? And if it is, great, we found it. If the middle element was something like 80, it basically only searches to the left of the array because 75 could not be to the right of 80. Okay, so essentially, like I said, I'm not going to explain binary search in detail, but just know that binary search does depend on the data, does depend on the array being sorted already in increasing order. So with that said, I am actually going to make a copy of this array because I might want to keep these initial original array values because they are connected directly to the people in terms of the ordering, but I might actually want to make a copy of these array values where I could sort them to do some basic statistics, and that's exactly what I'm going to do right now. So I'm going to go ahead and I'm going to make an integer array, a new one, and I will call this A scores sorted. And I'm going to say that's equal to arrays dot, and we're going to use a new method, CopyOf. Okay, you can see CopyOf takes two parameters. It takes an array, which is going to be the original, what we're going to make the copy from, and then it takes the length, basically how many of these elements do I want to copy. So typically you're going to want to copy all of them, so that's exactly what we're going to do here. We're going to go ahead and pass in, we'll pass in the original array, which is just A scores, and then the length will take A scores dot length. Okay, so that's just the safest way to say, hey, I want to copy everything in there. Okay, so now my A scores sorted. Okay, I'm going to go ahead and I'm going to print that out, my quick and dirty print, and then when I'm doing my search, I'm going to search through A scores sorted. Okay, so now you'll see whenever I run this, here are my original scores. And okay, so I must have printed off the, oh sorry, we haven't sorted it yet. My apologies. We've made the copy. We need to then go ahead and sort it. So we do the arrays dot sort. Okay, and Eclipse isn't always the best at auto-suggesting. We do sort, and then we pass in A scores sorted. Okay, so now what we'll see is we've made this copy of A scores, and then we sorted it. So now A score sorted truly is a sorted array, and we see that very clearly because here was the original order, and you can see the sorted order is in increasing order. Okay, so let's go ahead and run this a few more times to make sure it's working correctly. So here 75 is on the left-hand side, and that's correct, right? There is a perfectly average student. This time you can see only 75s on the right hand side. There is a perfectly average student. So my binary search does appear to be working. You can see 75s on both the left and the right hand side of this entire array. So there is a perfectly average student in your class. Okay, so let's continue on. I'll go ahead and comment out that quick and dirty print. So we just have, there's a perfectly average student in your class. And now the next thing I want to do, really the last statistical thing I want to do is very simple. I want to gather the top 50% of the grades. So maybe I want to send out a message to my students saying, hey, here's the top 50% of the grades. If you see your grade in this list, you basically know that you are in the top half of your class. Okay, so how can I do that? Well, I'm going to make another array here. This time I'm going to say int array A scores top half is equal to, and just like we did here, we're going to say arrays dot, but instead of copy of, I'm going to say copy of range. Okay, so this is a new method where we can basically take very specific pieces of our array and create a subarray out of it. So in this case, I'm going to copy from A scores sorted, right, because those are sorted in the proper way for me. And in this case, I want to take the top 50%. So I'm going to start at A scores sorted dot length divided by 2. So I'm going to start right in the middle. And then I'm going to go all the way to A scores sorted dot length. So I'm basically taking that top 50%. Okay, so I'll go ahead and finish that line of code, and then I will basically do a little bit of a print statement. We'll just do a system.out.print, and we will say something like this. If student score is in the following list, student is in the top half of the class rankings. I'll do a space right there. Okay. And then finally, let's go ahead and print out those results. So we'll do that for loop again. We'll say for int I equals 0. This time I'm going to do I, since I'm just kind of iterating through a bunch of scores. So for int I equals 0, I is less than A scores top half dot length I plus plus. I'm just going to iterate through each of those scores. And then I'm going to system.out.printf. And in there, I'm going to take as my formatted statement a %s followed by the % symbol. Okay, so I'll just say A scores sorted top half at index I. Okay, and then of course I also want to add to the end of that maybe a few spaces. Okay, so if student scores, let's go ahead and add a tab to the beginning there. Okay, if student scores are in the following list, student is in the top half of the class ranking. So you can see here the top two, 70 and 85%. We can run it a few times. You can see this time 85 and 70, 80, 75, and so on and so forth. Okay, I got a few typos here. Rank ins, and then if student score should be student scores in the following list. Okay, so the very last thing I want to do is I want to show you how to convert this array to a list. Okay, and it's very simple. I'm basically going to create a new list. I'll give it a data type of integer. Okay, and I'll just give this a name, something like list scores. Okay, and I'll say equals arrays, and there's a method as list. And I simply pass in my A, in this case, scores. Okay. Now what you'll see here is there's a little bit of an error. You can see it says change type list scores to list int. Okay, so the first thing I wanted to make sure I do is I import list from java.util. And essentially what it's actually complaining about is my list can only take the wrapper versions of primitives. So I can't have a list of ints, can't have an array list of ints, or really any data structure with ints in it other than arrays. they take the wrapper version, so integer. So in order for me to actually be able to do this, I actually need to go back and change all of my ints to integers. It's not going to change this code at all. And the reason I did this on purpose because I almost always just use int for my data type for arrays. That said, if you do want to convert it to an array list, you will need to, at least I should say, if you want to convert it to an array list using the as list, you will need to go ahead and update all these to integers. So I'll go ahead and you'll see, sorry, not that one. My A scores, I'll change it to integer. Okay, and that's going to give me a few errors. I'm just going to basically need to change int to integer all throughout my code, which is really just the places where I ended up making the copy ofs, and then the copy of range right here. Okay, but you can see once I do that, this code does indeed work. So what I can do now is I would do a system.out.print. I'll do a printf. I'll just do a few new lines. Okay, and I'll say list scores. So they're just the list version of these scores. And I'll say size %s, and then %s with a new line. And I'm going to say list scores. So the main thing is if you want access to these list methods, things like size, you can now get access to those. List scores dot toString. You can see I can call that toString method right off the array. And you'll see it's basically, this is a quick and dirty version, right, of this print, but nevertheless it does still print out, and we do have this in list format. Now I do want to point out the list, this is actually an interface. You cannot actually change this data structure. You can't actually add or remove values, which is the main reason to actually convert to something like a list. So essentially what we need to do if you do want to modify this list is you need to convert it to something like an array list. So the last thing we'll do here is we'll create an array list of integers. We'll call this AL scores, say equals new array list of integer. And what I typically do is just in the constructor itself, I'll just pass list of the scores. Okay, make sure we import array list, and you can see that code will work just fine. So just to demonstrate that this did work, we can say AL scores dot add, and maybe I add 100, that perfect student. Okay, and then I can say system.out.print line, and I'll go ahead and I'll just add a new line here. Say AL scores, do the same thing, size %s, and then %s to actually print out that quick and dirty print. So we'll say AL scores dot size, and then AL scores dot toString. Okay, this needs to be a printf. Okay, so now we can see 80, 70, 75, 65, 100. So you can see I now have this array list, and I can actually add things to it. I can add scores to it. If you do want this to be sorted, it's very simple. Just go ahead and call AL scores.sort. So this is a nice thing about arrays or array lists. You don't need to call arrays.sort. The object itself has an array method. If you just want to do a standard sort for something like numbers, just pass in null, and you'll see that it'll sort it. So you can see 70, 75, 75, 80, 100, and so on and so forth. Okay, so that is arrays, right? That is arrays, both single dimension arrays and 2-dimension arrays. So I hope you enjoyed this video. If you did, be sure to smash that like button and subscribe to the channel. We got some really cool stuff coming up. Thanks.